In this section, we're going to go over some basic mathematics. We're going to see this math throughout this short course, and you will also see it in your upcoming microecon courses. So we're going to cover graphing, equation of a line, how to graph these linear equations, min and max values, and simple derivatives and rules. So first let's talk about graphing. So this graph is a representation of a demand curve. On our y-axis we have price, on our x-axis we have quantity. And even if you don't really know anything about demand functions at this point, you can kind of get an idea just by looking at this graph. So we see that as quantity increases, price will decrease. So this is just a very typical relationship that we see in our demand curves. So we can take this graph and we can represent it as a function. And we say y is a function of x. And most of the demand curves you're going to see in this course are linear functions. So we write f of x equals a plus bx, where a is the y-intercept and b is the slope. So our quantity demanded and our quantity supplied are written as linear functions, and they're written in terms of price. So one thing we do in economics, which is different than other sciences, is that we like to write our explanatory variable on our y-axis instead of the x-axis. So this can cause a little bit of confusion, but all you need to do is write in terms of q instead of writing in terms of p. So for example, if we have our quantity demanded as a function of p being 8 minus 2p, we can just rearrange and write p equals 4 minus 1/2 q. And then this is what you'll want to graph on your y and x. So we can do the same thing for quantity supplied. So if quantity supplied is 1 plus 1/2 p, we can rearrange and write p equals negative 2 plus 2q. So in this case, the constant of the front will be the y-intercept, and then the coefficient on the quantity will be the slope. So the equation of our line, recall, is y equals what the y-intercept is plus the slope multiplied by x. So given a table of values, we can actually put together this equation of a line. So we need two things. We need the y-intercept and we need the slope. So how do we calculate the slope? Well, all we need is 2 points from this table of values. So remembering from your high school math, slope equals rise over run, or change in y over change in x. And this is simply equal to the difference between p2 and p1 divided by q2 minus q1. And the y-intercept is simply the point where your line crosses the y-axis. So that means x equals 0 at that point. Or in our case, quantity will equal 0. So how do we translate this table of values into a functional form? Well, let's pick the y-intercept out of our table. So if you look at the bottom of the table, we have a quantity demanded of 0 and a price of 1. So that means our y-intercept is 1. So we're halfway there. So now how about the slope? So we can take any 2 points that we want. So let's just take the first 2 points. So the 100 and the price of 0, and 75 and the price of 0.25. Plugging those into your slope equation, you're going to get a slope of negative 1 over 100. So notice that the slope is negative, and this is again typical for demand because we have that downward sloping demand curve. So plugging all this information into our equation, we get p equals 1 minus 1 over 100 qd. So we call this the inverse demand equation. So you'll see it written q in terms of p and also p in terms of q. So we can also take graphs and interpret the linear equation from them. So again, all we need is the y-intercept and the slope. So on this graph, let's take a look at the supply equation. So the supply equation is the line that's sloping upwards. So we have a positive slope in this case. And notice the y-intercept is at 10, and we have another point on the line, it's at 10 and 20. So taking those points, we can calculate the slope. Again, that's just rise over run. And we can pull out that y-intercept and plug all of that into our linear equation to calculate our equation of the line. So doing so gives us a slope of 1, and our y-intercept is 10. So plugging that into our inverse supply function, we get p equals 10 plus qs.